The lugs and pool pump and waterfall pump can be used to bond to the equipotential grid of the pool's in-ground rebar. Here is the general process for grounding a pool and its equipment. Firstly, install a grounding grid around the pool. This can be accomplished by burying copper wire or rebar around the perimeter of the pool. This grid must be connected to grounding rods for effective grounding. Secondly, connect the grounding grid to the grounding bus in the electrical panel. This connection provides a low impedance path for electrical current to flow back to the source in the event of a fault. Thirdly, connect the grounding conductor from both the pool pump and the waterfall pump to the grounding grid. This bonds the pumps to the grid, ensuring that any stray voltage is minimized, thereby providing protection against electrical shock. It is important to adhere to certain additional notes to ensure that the grounding system is installed safely and effectively. The grounding conductor should be sized according to the National Electrical Code or NEC. Consult NEC Table 250.122 to determine the appropriate size of the grounding conductor based on the overcurrent protective device in the circuit. The connection between the grounding conductor and the grounding grid must be made with a listed grounding clamp. This ensures a secure and reliable connection that will not corrode or loosen over time. It is also critical to bond the equipotential grid to all metal parts of the pool. This includes the pool ladder, diving board, slide, and any other metallic components that could become energized. This bonding minimizes voltage gradients in the pool area, further reducing the risk of electric shock. The purpose of equipotential bonding is to create an electrical connection between all metallic parts within and around a swimming pool. This includes the pool reinforcing steel, metal fittings, pump housings, metal conduit, and any other metallic items that could become energized. By bonding these items together, the voltage difference between them is minimized, reducing the risk of electric shock to anyone in or around the pool. The NEC, specifically Section 680, provides detailed requirements for equipotential bonding of swimming pools. These requirements are intended to ensure that the bonding is done correctly and effectively. The bonding grid typically consists of a number 8 AWG solid copper conductor that is run around the perimeter of the pool and connected to all of the metallic items mentioned above. The conductor must be buried at a depth of at least 4 inches below the ground surface. The bonding grid must also be connected to the pool's reinforcing steel. This can be done by welding the bonding conductor to the rebar or by using listed bonding connectors. In addition to the bonding grid, the NEC also requires that all electrical equipment associated with the pool, such as pumps, filters, and heaters, be bonded to the equipment grounding conductor. This conductor provides a path for fault current to flow back to the source of power, tripping the circuit breaker and energizing the equipment. The equipment grounding conductor must be sized according to NEC Table 250.122. It must be installed in the same raceway or cable as the circuit conductors. When installing an equipotential bonding system, it is important to follow all of the requirements of the NEC. This will help to ensure that the system is installed correctly and effectively, and that it will provide the maximum level of protection against electric shock. It is also important to have the installation inspected by a qualified electrical inspector to ensure that it meets all of the applicable requirements. There are several key reasons why equipotential bonding is so important for swimming pool safety. Firstly, it reduces the risk of electric shock. By minimizing voltage differences between metallic parts, the risk of electric shock is significantly reduced. Secondly, it provides a path for fault current to flow back to the source of power. This allows the circuit breaker to trip and de-energize the equipment, preventing a potentially dangerous situation. Thirdly, it helps to protect against corrosion. By bonding all of the metallic parts together, the risk of galvanic corrosion is reduced. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as water. The more active metal will corrode, while the less active metal will be protected. Equipotential bonding helps to prevent this type of corrosion by ensuring that all of the metallic parts are at the same electrical potential. Fourthly, it helps to improve the overall safety of the pool. By reducing the risk of electric shock and corrosion, equipotential bonding helps to make the pool a safer place for everyone. In summary, equipotential bonding is a critical safety feature for swimming pools. It helps to reduce the risk of electric shock, provides a path for fault current to flow back to the source of power, helps to protect against corrosion, and improves the overall safety of the pool. When installing an equipotential bonding system, it is important to follow all of the requirements of the NEC and to have the installation inspected by a qualified electrical inspector. Additionally, it's beneficial to understand a few more specific details about pool grounding and bonding. The grounding electrode system is a critical component. This system typically involves ground rods, but can also include metal underground water pipes or concrete encased electrodes, often referred to as UFA grounds. The NEC specifies the requirements for these grounding electrodes, ensuring a low resistance path to earth. The purpose of the grounding electrode system is to stabilize the voltage to earth and provide a path for fault current to return to the source. When connecting the grounding and bonding conductors, use approved methods and materials. These include listed grounding clamps and connectors that are suitable for direct burial. Avoid using wire nuts or other unapproved connectors, as they can corrode over time and compromise the integrity of the grounding system. Make sure that all connections are tight and secure. Regularly inspect the grounding and bonding system to ensure that it is in good condition. Look for signs of corrosion, damage, or loose connections. If you find any problems, have them corrected immediately by a qualified electrician. When working with electrical systems, always take necessary safety precautions. This includes turning off the power to the circuit before working on it, wearing appropriate personal protective equipment or PPE, and using insulated tools. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Understanding ground fault circuit interrupters or GFCIs is also paramount. GFCIs are designed to protect people from electric shock by monitoring the current flowing in a circuit. If the current flowing out of the circuit differs from the current flowing back in by more than a few milliamperes, the GFCI will trip, cutting off the power to the circuit. GFCIs are required for all electrical outlets within a certain distance of a swimming pool. They are also required for all electrical equipment associated with the pool, such as pumps, filters, and heaters. Regularly test GFCIs to ensure that they are working properly. This can be done by pressing the test button on the GFCI. If the GFCI does not trip when the test button is pressed, it should be replaced. Surge protection is another important consideration for pool equipment. Power surges can damage sensitive electronic equipment, such as pool pumps and heaters. To protect against power surges, install a surge protector on the electrical circuit that feeds the pool equipment. Surge protectors are available in a variety of sizes and types. Choose a surge protector that is appropriate for the equipment that you are protecting. Also, consider the materials used for pool construction. Saltwater pools, in particular, can be corrosive to certain metals. Ensure that all metal parts in and around the pool are compatible with saltwater. Use stainless steel or other corrosion-resistant materials when necessary. Proper maintenance is essential for ensuring the longevity and safety of your pool's electrical system. Regularly inspect the equipment, test the GFCIs, and keep the area around the equipment clean and dry. By following these steps, you can help to ensure that your pool is properly grounded and bonded and that it is safe for use. Remember to always consult with a qualified electrician for any electrical work related to your pool. They can ensure that the work is done safely and in accordance with all applicable codes and regulations. Specifically regarding the Waterfall pump, ensure its bonding is equally robust as the main pool pump. Both pumps are critical components, and any failure in their grounding could present a hazard. Verify the voltage and amperage requirements of both the pool pump and the Waterfall pump. This information is typically found on the nameplate of the equipment. Ensure that the electrical circuit is properly sized to handle the load of both pumps. The wire size, breaker size, and other electrical components must be appropriate for the total amperage draw. In addition to the bonding of metal parts, consider bonding any nearby metal fences or structures. If a metal fence is located close to the pool, it should be bonded to the equipotential grid. This will help to prevent the fence from becoming energized in the event of a fault. The bonding connection to the fence should be made with a listed bonding connector. Also, if there are any metal structures, such as gazebos or pergolas, near the pool, they should also be bonded to the equipotential grid. This will help to create a safe environment around the pool. The connection to the structure should be made with a listed bonding connector. Furthermore, consider the location of underground utilities. Before digging around the pool area, always call the local utility companies to locate any underground utilities. This will help to prevent damage to the utilities and ensure your safety. The utilities may include gas lines, water lines, sewer lines, and electrical lines. Hitting one of these utilities could be dangerous and could also disrupt service to your home or neighborhood. The placement of lighting around the pool is very important as well. Ensure that all lighting fixtures are suitable for wet locations and are properly grounded. Use low voltage lighting where possible, as this reduces the risk of electric shock. Position the lighting fixtures so that they illuminate the pool area without creating glare. Glare can make it difficult to see and can increase the risk of accidents. Consider using underwater lighting to enhance the aesthetics of the pool. Underwater lighting can create a beautiful and inviting atmosphere. However, it is important to use lighting fixtures that are specifically designed for underwater use. These fixtures are typically sealed to prevent water from entering and are made of corrosion-resistant materials. Remember, local codes and regulations may vary. Always check with your local building department or electrical inspector to determine the specific requirements for your area. They can provide guidance on the installation of the grounding and bonding system, as well as other electrical requirements for your pool. Staying up to date with the latest codes and regulations is essential for ensuring the safety of your pool. There may be changes to the NEC or local codes that affect the installation or maintenance of your pool's electrical system. It is important to stay informed about these changes and to make sure that your pool's electrical system is in compliance. If you are not sure about any aspect of the electrical system, consult with a qualified electrician. They can provide expert advice and ensure that your pool is safer and code compliant. Regarding the grounding rods, they should be at least 8 feet in length and should be driven into the ground until they are fully buried. The rods should be spaced at least 6 feet apart. The grounding conductor should be connected to the rods with listed grounding clamps. The grounding conductor should be sized according to the NEC. It is also a good idea to have a professional conduct periodic inspections of your pool's electrical system. A qualified electrician can identify potential problems before they become serious and can ensure that the system is operating safely and efficiently. The inspection should include a visual inspection of all electrical components as well as testing of the GFCIs and other safety devices. If any repairs are needed, they should be performed by a qualified electrician. The goal is to create a swimming pool environment that is not only enjoyable, but also exceptionally safe from electrical hazards. By meticulously following the NEC guidelines and implementing best practices for grounding, bonding, and GFCI protection, it is possible to significantly minimize the risk of electrical shock and ensure the well-being of everyone using the pool. Remember to prioritize safety above all else and to consult with qualified professionals whenever necessary. By following these guidelines, you can help to ensure that your pool is properly grounded and bonded, and that it is safe for use.